Hello. Okay, so welcome to Engineering 99. Hopefully you remember stuff from last semester, so we're going to jump right into this question. If you have any doubts, feel free to raise your hand, but know that you will be judged by all your peers, and you might expose your weaknesses.
Think about your answer carefully. How confident do you feel about your skills to succeed in this subject?
According to the National Girls Collaborative Project, the rate of women and minorities enrolling in STEM courses shifts at the undergraduate level as a racial and gender disparity in STEM majors emerges. In 2013, women received only about 19% of physics, computer science, and engineering undergraduate degrees. That same year, underrepresented minority women received only about 5% of these degrees. Furthermore, after selecting majors, women are 50% more likely than men to switch out of a STEM major, even when controlling for academic ability. So clearly, the issue of a homogeneous population among STEM majors is a systemic one.
Our study is one of the first to look into the relationship between the effects of active learning methods and self-efficacy in introductory STEM courses. Based on our findings from last year's focus groups, we investigate the relationship between iClickers, a common form of active learning at Duke, and self-efficacy.
So self-efficacy is the measure of how much conviction you have to successfully complete tasks that will get you to your desirable outcome. So a psychologist Bandura, in 1977, hypothesized there are 4 factors that affect self-efficacy. Firstly, vicarious learning. So this is a perception of how you think your peers around you are either succeeding or failing. Secondly, the amount of anxiety. Thirdly, verbal encouragement, which is the recognition you receive from both your peers or your instructors about your performance. And 4, the mastery of the subject that you have. So Bandura hypothesized that the amount of self-efficacy you have determines how you will react towards obstacles that arrive in your path when completing your goal. And your interpretation of how these experiences that you had to overcome these obstacles will then, in effect, determine your self-efficacy. So in this project, we try to figure out how both men and women at Duke progress through their STEM majors.
So in our study, we divided students into 2 groups. If they were in the control group, they sat through a lecture, so they had passive learning. If they were in the experimental group, they had a class with iClickers. Students learned one of 3 subjects: economics, engineering, or statistics. Based on our research, we collected data from pre- and post-tests in our sessions that kind of showed how they felt about the material and their confidence in answering some questions. Based on this, we had a few results. In it, that we found that both male and female students had increases in self-efficacy in both the passive and active learning sessions. Our results were inconclusive. However, this may be due to the small sample sizes that we had.
So now think back to the original question. What was your answer? So if you were in an active learning class, this is what you would see next. You would see a distribution of what your peers around you answered. If you guessed B, you got the right answer. So hopefully you now feel more confident and ready to succeed in the class. However, if you got the wrong answer, you recognize that there are lots of people around you who are also on the same boat as you and willing to learn.
In the future, specifically next year, we hope to build on the results from this study by studying a wider variety of active learning methods, such as team-based learning, project-based learning, or reflecting during class about how you're feeling about the subject or making personal connections. Ultimately, we hope to discover if active learning and introductory STEM courses will increase retention rates of women and minority undergraduate students in STEM fields. Thank you.